within 5 to 10 minutes. Please wait. Other are joining. Let's. Good evening to all of you. Today we will discuss second assignment of the previous year, not the current assignment. Let me share slides. Can you see my screen? Hello, can anyone reply? Hello, Shailesh.
Slides are not visible.
Wait. Now?
Now it is visible.
Okay. Maybe internet is slow. So today we will discuss second assignment of the previous year. Basically, we will discuss the unit cells and Miller indices. So first question of the assignment second is shape of the primitive cell of FCC lattice is cubic, parallelopiped, and monoclinic or orthorhombic. Please answer the question. Try to answer the question. Your interaction session will be count for the marks in the examination. So what will be the answer? You can type in chat.
Sir, I think B.
Yeah, it should be B. So let's see. Do you know primitive cells? What is primitive cells? How many atoms should be in the primitive cells? One or two?
Atom should be at the corners. Lattice point should be at the corners for primitive cells.
So what will be the contribution? Whole corner sharing should be one or two for primitive
One.
unit cells.
One.
One. Okay. So in FCC, you don't know how many atoms are present.
4 atoms in FCC.
Four atoms. So how can we concrete? How can we cell make primitive cell? So let's see the answer. You have to choose a origin and ABC translation vector in a such a way smallest unit cells we have to achieve. So you can see we have to join. Let's see here we join centered atom, face centered atom. Are you able to see my pictures in the slide? So this is dotted lines with ABC vector. R is a primitive unit cells and yellow pipes in shape. Yes, are you agree, Salesh?
Yes, sir.
Okay, so let's go more right. The symmetric operation present in a 2D crystal lattice is a in 2D. Inversion, reflection, rotation, and skew. So answer the question, please. So let's discuss. Answer will be reflection and rotation. So sir has already told in class and discuss these things. 1D in 1D have two type only translation and reflection, mirror image and translation in 1D, and 2D translation, reflection and also rotation, and 3D translation, reflection and rotation, and fourth inversion. So remember these things. Okay, this is the answer B and C. In 2D you can see translational, rotation and reflection. So only reflection is there and rotation. Inversion, no. Screw, no. So clear this question?
Screw symmetry operation in 2D crystal lat.
Why? Your voice is not
Why don't
clear.
we have screw symmetry operation in the 2D crystal lat?
Symmetric
Screw, the option 4.
will
Why
be
don't we have screw? Yeah.
so answer is only reflection and rotation. B and C
Why don't we consider screw?
should
Screw
be
symmetry operation.
screw. Are you saying D option is correct?
Yeah, if I select screw symmetry operation,
Mhm.
it will be correct or wrong?
It will be wrong. Answer will be reflection and rotation. I think sir is not discussing in the class. This type is symmetric. So leave it. Only sir is discuss translation, reflection and rotation. If you more interested, we will discuss.
Okay.
Okay. So next question. I think my slide is not. I'm on third question, but still I think second question are visible. Yeah, now it's coming. So number of the primitive lattice in basis lattice, body centered cubic. Primitive lattice says in a basis lattice is what will be the answer? 2, 3, 4, 1.
So
So let's check how 1, 2, 3, 4, 7. This is the corner sharing atoms and one should be in center. So this is the totally occupied by the unit cell 1 and corner sharing atom. This is if we can if we further extend the unit cells, so corner sharing atom sharing in the unit cell will be 1 by 8. So how many corner sharing atoms? There is 8, and the probability of sharing is 1 by 8, and plus 1 is the center. So answer 1 plus 1, 2. Okay, so next question regarding the which will which of the following is the correct relationship between the lattice parameter of the orthorhombic crystal? Orthorhombic crystal systems. So please answer the question. A is ABC length parameter are equal and alpha, beta, gamma angles will be 90. B option length ABC are not equal and alpha, beta, gamma are equals and equal to 90. And C option A equal B equal C and alpha, beta, gamma not equal. And D option ABC A equal B but not equal to C, alpha beta equal to alpha beta 90 and gamma not. So what will be the answer? This is the simple question. You should remember. Hello. Please answer the question. You can write in chat box if your voice is not properly. Please write the answer in chat box. Okay. Shailesh, are you there?
Yes, sir. Yes.
Please answer the question.
I also think B.
Okay. So answer is B. Please remember these 7 crystal systems. Cubic length are equal and alpha beta are also 90. Tetragonal and A or B are equal but not equal to C. Alpha beta gamma are 90. Monoclinic length are not equals but alpha gamma are 90 but not equal to beta 90. Orthorhombic length are not equals but this is the alpha beta gamma 90, and triclinic hexagonal and trigonal. So when we calculate D, do you know formula? Spacing between the plane. This angle also play a role. If angles are 90, then we will simply calculate D. But alpha beta not are 90s, then formula are different. And what is the formula of D? Interplaning distance for alpha beta gamma are 90. Anyone has idea about this? What is the formula of D spacing? Relation A, B, C and HKL. Shailesh, please answer the question. It's just simple formula. This is right or wrong? Please type in chat box yes or no.
Yes, it is right.
Okay, thank you. So, system are important for this relation. If the question is like that, your system is, let's say, orthorhombic. So, first verify the alpha, beta, gamma. So, you have to remember relation between alpha, beta, gamma and ABC also. Okay, if a system is like that, alpha, beta are 90s, then we can calculate spacing of the interplanar distance of the planes by this formula d equal to 1 upon h square by a square plus k square by l square plus l square by c square का whole square root if alpha beta gamma are 90 and others system like hexagonal trigonal may be calculated by another formulas which will be include the angle also. Okay, so let's move further. A face centered cubic FCC unit cell is not reduces as two body centered tetragonal BCT unit cell because of the FCC unit is bigger than the BCT unit cell. The FCC unit cell contains more lattice points than the BCT unit cell. Symmetric of the BCT unit cell is higher than the FCC unit cell. What will be the answer? Have any idea? So what will be the answer? Sir already discussed I think in class symmetry and smallest uh, distance like that when we have choose the system BCC FCC. So answer sorry I think D is missing here. I have to correct. Sorry, answer is D. I have forget to mention that option D. Symmetry of BCC unit cell is higher than the so this is FCC threefold fourfold three symmetry threefold fourfold symmetry and six twofold symmetry. So why B FCC is not B reproduces as a BCT? Answer is symmetry. FCC has a more symmetric than BCT. So when we system choosing, we have to clearly first is symmetry, second is smallest distance of the primitive lattices. Please remember these things. Next question. The coordination of the atoms in a body-centered cubic unit cell is. My slide is not moving. Let me correct. There is also the option. Please wait. One minute. Give me next question. What is the next question? Please think about this question and answer me.
Well, sir,
Yes.
sir, the correct option is not here, I think. It
Uh,
is 8.
okay, okay. So you have to think now. So how to let me correct the slide. Please wait. Yeah, answer is C at how this is. So that's correct. So how this is? Let me draw and show you to how this is possible. Coordinate number of the atom in a body-centered cubic. So let's say, give me a simple example. Let's say, so we have an atom like that in a distance. Another atom. This is root 2a distance. Let's say. So for the this red centered atom, what will be the coordination number in 2D? Now please answer. This atom, let's say, bigger in size and touch each other like that. This is the distance A with the centered atom. So what will be the coordination of red atom here? Shailesh, please. Please answer now. 4. Okay. So nearest atom set in touching or with the reference atom. How many? These are 4. So coordination will be 4. Clear? But let's see here how many atoms in cubic system with centered symmetry. We have a, let's say, centered atom here. How many atoms will be? 8 are the corners. Let's choose another color. And if you draw similar or extended unit cell. Similarly in below. So what will be the nearest uh, atom? Please answer the first. What will be the nearest atom? The corner or the centered atom of the adjacent unit cell? What will be the distance this and this? And let's say another here, this and this. Which distance is minimum? Centered atom or corner atoms? Yes, please. What will be the diagonal distance of a cubic? Root 3a or something else? If the parameter a, lattice parameter ab is equal to a. This is the diagonal distance. Yes or no? So by 2, this will be the distance. And what will be the this distance? Let's say have a two faces are in touch. This is a length, one atom here and one other atom here. So this is a by 2, this is a by 2. So what will be the distance? A or something else? So which is more, this or this? This is right or this is right? Shailesh, root 3a by 2 is more or a? Hello, this is root 3, value of root 3. So okay, a is more. So like that we have 8 adjacent cells such type: below, up, down, back, forth. So this type of black atoms will be 8. So why this is coordinate is 8 number. Clear? I think. Can we move further? Okay. Next question. Following regions explain the absence of the end-centered cubic lattice among various Graves lattice. Why is 7 only has a 7 system now only have 14 Graves lattice? Why not 7 to 7 into 4, 28? Sir, I think has discussed in class. Yes or no? Should be 28 now. But why is not 28? Only has a 14. Do you have any idea why is not 24? So answer is A and D. So violate the symmetric requirement of a cubic lattice, and it can be represented by a simple tetragonal lattice. So, sir, I think already discussed in class C-centered cubic. If we let's see why region explains the absence of the end-centered cubic center among the various Brazilities. If we include the cubic system, end-centered or C-centered, it is simply represent a, I think is already in simple cubic tetragonal cells. So this is why not 28 only has 14s. And another first is symmetry, second is the distance of the lattices points. Next question: which of the following rotational symmetries are not present in the periodic points lattice? Option 3 4 4 4 5 4 9 4 C and D. Why C and D? Why? Answer is correct, but why? Hello. Yes, Alice.
It is not possible because uh, when we join the fivefold symmetry,
Yes.
it's not properly. Some spaces remain between them, so it is not uh, completely.
Yeah.
We can't form a crystal.
Yes. Yes. So
Repetitive.
we not cover the entire space
Ah,
if we consider the fivefold. Yes. No.
yes, yes.
Okay. Simply so. Yes. Sir already has discussed gaps are remains. So if we consider the fivefold symmetry, so we not easily fulfill the whole space if we consider the fivefold symmetry. So answer this. So, crystal system not found in fivefold or ninefold. Also ninefold. So hence fivefold is not counted in the periodic crystals. Next is how many of the 14 Bravais lattice contain two lattice points? Please answer this question. You have a 5 minutes. Please draw the unit cells and check which system is contained 1, 2, 3 unit cells of Bravais lattice. Please draw. I think. Let's see. 7 system you have, and has cubic also face centered and body centered like that. Please, one is answer is 4, another is 6, 5. So what will be the correct answer? Please carefully look and understand. Yes, 5 is answer. So how? Let's see. We know the corner sharing is only sharing is 1. Yes. If a body centered is also, so body centered totally occupied is 2. So cubic first. Yes. Which type of files are present here? Like a cubic. Another is, you can say in the table here. Can you answer the tetragonal is yes or no? Orthorhombic, rhombohedral, hexagonal, and let's say this is centered cubic. If this is face centered, this is face centered. So answer ortho, body centered, and face centered. Okay. So I give a hint. Corner sharing is 1 by 8. Okay. Centered, if a centered atom is present, totally occupied by 1. If a centered, how many? What will the probability? 1 by 2. Yes. This is corner sharing. This is centered, generally represented by a face centered. So this is the hint. You can calculate by yourself. Please find the system and which type of looks like, where is the atoms present. Then you can easily calculate number of atoms are present in the system. Yes. Okay, let's move further. The defining symmetry of the cubic crystal system is, what will be the answer? Option A, threefold, fourfold. Option B. So option B is right. So please remember these things. Sir, I think is discussed in class. Only system should be include 4 3-fold symmetry, then will be the cubic. If this symmetric is not present, then system may be another. This is necessary condition. Other symmetric may be present, but this is necessary for the cubic system. And tetragonal, 1 4-fold symmetry. Orthorhombic, 3 2-fold symmetry. And this is the notation in between symbol. And tritemic is least symmetric, none. Any symmetry is not present. 1 2-fold symmetry present is monoclinic. Rhombohedral is also 1 3-fold. And hexagonal is 1 6-fold symmetry. Yes, let's move. A set of identical crystallographic planes in a crystal system is denoted by HKL. Family of planes identical at crystallographic planes or family of planes represented by which symbol? Option A, B, C, and D. Please answer. Shailesh, are you there? And Dr. Dolor, what will be the answer? Notation regarding the family of planes or identical crystallographic planes. Let me show you answer. So answer is curly bracket represent the family of planes. So please remember one plane is simple this bracket. This is represent one plane. This is represent by family planes, identical sets of planes or family of planes. If HKL are Miller indices here and in the crystallographic direction UVW single plane, this bracket is represent set of directions. So please remember these brackets symbols. Next question. If the intercept of a plane on x, y, z direction are 3a, 2b, 3c are a lattice parameter represent Miller indices. What will be the Miller indices? You have a 5 minutes. Please solve this question. Do you know how to find the Miller indices? You have a 5 minutes. Please try to solve this question. Hello. So, what will be the answer? Can I discuss? If you are not able, let me discuss. How find the reciprocal in lattice. First, intercept. You have to given the intercept 3a, 3b, and 2c. Take inverse of the numbers 1 by 3a, 1 by 3b, so 1 by 2c, and abc is above. Cancel out 1 by 3a, 3, sorry, 1 by 2. Take LCM of this number 3, 3, and 2, 2, 3. So LCM 6. Multiply by this LCM. So 3 2 is 6, 3 2 is 6, and 2 3 is 6. HK 2, 2, 2, and 3. And this is represented by symbol 2, 2, 3. So this is the answer 2, 2, 3. Are you able to understand? Do you copy me? Okay. So, and this is the procedure. Let me reach. First, define the origin, determine the intercepts. So we have already with intercepts. Question: take the reciprocal and convert the smallest set of integers. This is the procedure. Sir, I think already discussed in class. Okay. Can you find the reverse? Let's say question such like that. You have a question. You have a 2, 2, 3 HK. Can you find intercepts? Please find the intercepts on axis, on x, y, z axis. So you can convert reciprocal. We have first reverse the process. I think you can easily get the intercepts 2, 2, 3. Take the inverse and smallest integer, convert into the smallest integer. Next, multiply by 6. So when we multiply by 6, 2 3s are 6, 2 3s are 6, 3 2s are 6. This is the intercept. So question may be like that, or maybe HKL. Question may be asked in HKL or maybe intercepts. So prepare both types. Okay, let's move further. The angle between this 102 and 111 direction in the cubic lattice. Can you find the answer? You have a 5 minutes. Or for cubic system, let me cosine theta equal to u1, u2, uvw. So guys, today we have discussed assignment second that discuss teaching. First question we have discussed today. First question is shape of perspective, cell of FCC lattices, cubic, parallelepiped, monoclinic. So answer is parallelepiped. We can see the answer in image if we join centered lattices, lattice points, which is the smallest distance, then we can find our system is parallelepiped. Second is the symmetry operation present in the crystal is our we have discussed second question. Answer is reflection and rotation. Third, we have discussed in class. 1D has translation, reflection, 2D translation, rotation, reflection, 3D translation, rotation, reflection, and rotation. Third question we have discussed the number of the primitive lattice in the BCC lattice is 2, 3, 4, 1. So we can see one is sharing as the 1 by 8 sharing the cubic cell, and one is the center. So at corner 1 by 8 sharing plus 1 according to the center. So total is 2. And which of the following is correct relation between the lattice parameter of the orthogonal crystal system? So the answer is D. Please remember these things. Cubic, tetragonal, isomorphic, trigonal, hexagonal, and trigonal. These are the length parameter angle predictions. This will be include both the calculated interspacing distance. Because a center-faced cubic cell is not reduced as the two-body center tetragonal PCT unit equals. These are the options, and the answer is D. Answer as discussed in class. FCC has more symmetry than PCT, and the system has more symmetry than this is ideal choice of the system. First is symmetric, second is system. The derivation number of the atom in the body center cubic cell is 4683. The answer is H. Now you can see nearest touching atom is called coordination for this corresponding pattern. Here is 4. Similarly, we can find body center of the unit cell to be unit cells is a smaller distance with the adjacent group. So this is will be at adjacent cells and cells. So answer is 8. While following reason explain the absence of the ancestral to the data center in various proximities. It correlates the symmetry requirement of capabilities. It can be represented by the set of capabilities. It is not the validity space lattice. It can be represented by some particular lattice. So answer is correlate the symmetry requirement of capabilities represented by the determinants. Answer was discussed in class. Why it's not computed in class it is 14. So first choice is we see the symmetry of the systems and the distance. So some are common and falls into the another system. That's why which of the following conditional symmetries are not present in the periodic quantities? 3, 4, 4, 4, 5, 4, 4. So answer is 5, 4, 4 because some gaps are unfilled if we consider the 5, 4, and 4 symmetry of this place. Normally, 14 lattice contain 2 lattice counts. So answer is 5. You can see crystal system does lattice tube center recenter and center located governor for hydrogen has 4 tubes also has centered symmetry. So centered is centered. So you can calculate by both the side. If the one side presented the corner, side will be right inside. And the center is 1, the center is 5, 2. You can calculate the polar that defining center of the system is for cubic system of rotation. This is the defining system and crystal system. 4, 4, 2, 3, 4 spectral for cubic. 1, 4, 4 symmetric for determinant. 3, 4 determinant. 1, 4, 6, 4 hexagonal. And 1, 2, 4 quadrat. 1, 2, 4 triangle. These are the list. These are the list. This is the symbol. This is the necessary condition for and system. This should be present, otherwise the system might be different. So this is the necessary condition. Some other symmetry may be present. This is the critical set of identical crystal planes in the crystal system generated by crystal system. Set of respectively planes. So answer this is HKL to the bracket. Please remember HKL for one plane, curly bracket for set of planes. Particular direction. This is the direction. So then set of planes. Please remember this. Intercept. If the intercept of given h square introduces our criteria should be considered virtually where ABC are the greatest point from the indices of the graph. So we can for the procedure and explain this. Take the reciprocal and convert it to a smallest. So this is will be the answer to this. Every question like us is when the intercept of the inserted is h gap. So reverse the process again. Check the inverse. Convert it to a smallest. These are the intercepts within ABC. The angle between the projection of the two system. This is the formula. After putting these values in the formula, we will get concept which will verify the sign as will be the corresponding angle for the interrupt displacement by video form of the basic vectors parameter case interspacing distance d. So this is the formula. We have everything that is equal to the distance here. To put these values, again the answer is equal to 2.47. If you are on plane, so intersect first point intercept with axis, then mark points, then connect electrons. This is the